So dear students, in this video we are going to discuss our fifth experiment, that is BJT common emitter characteristics. The aim of this experiment will be to analyze and understand the common emitter characteristics of the BJT. So we'll be using the same virtual lab platform that we have used in the previous experiments. And we will choose this experiment, that is BJT common emitter characteristics, using the various links provided on this virtual lab platform. So if you select this experiment, you'll find this window will open up, and here you have this theory that that is just like you had in other experiments. Then you have the procedure that has to be followed for performing this experiment. Then here on this link you will find the model which is simulated. So we are coming directly to this simulation model. Here you will find that there are two links provided. First is your BJT input characteristics. We'll be discussing about the BJT input characteristics and how to perform that experiment in order to obtain the BJT input characteristics. So we'll be just clicking on this link, and this type of window will open up. That is BJT common emitter input characteristics. So coming to the instructions part, the first step says that initially you have to keep the rheostat RH1 and RH2 equals to 1 ohm. So here these two values RH1 and RH2 should be kept equal to 1 ohm. So we'll be simply changing the position of the slider in such a way that here 1 ohm is displayed. So again RH2 will be setting the slider so that 1 ohm is displayed here. Okay. So if you change the value of these two rheostats, you'll find the corresponding changes in VBE, IB, IC and VCB. Now the next step, it has been mentioned that we have to set the collector emitter voltage VCE to 1 volt by adjusting the rheostat RH2. So this rheostat RH2 is to be adjusted so that your VCE will be equal to 1 volt. So it has been adjusted here. I have already adjusted it. Okay, so here you have this VCE as 1 volt. Now if you just press this tab add to the table, you will find here in the experiment table your collector emitter voltage is displayed here, and the corresponding base current, base voltage and base current values are also displayed here. Now as per the instruction, this VBE is to be varied by adjusting the rheostat RH1. So this VBE voltage, it has to be adjusted by adjusting this value of RH1. Suppose we change this RH1 and we keep it as 5 ohms. Okay. Then your VBE will be 0.1000. So you can add this value by pressing it. You can take these values, or you can say the change in RH1 at regular fixed intervals, but here I am just taking it randomly. So don't just follow what I am doing. You have to take these values in the regular steps. Okay, like you are varying by 5 ohms, or you are varying by simply 2 ohms at each regular interval, or simply 1 ohm in each interval. Okay, so here we are again changing the value and just pressing this tab add to table, then your experimental table will come in this form. We will obtain the value of base emitter voltage and the base current at a particular value of collector emitter voltage, that is at a value of 1, it should be 1 volt. Actually I have committed one mistake. Let me clear all the values so that it comes again to 1. Then we have to adjust RH2 in such a way that your VCE should be equal to 1 volt in this way. Okay, here. So we have now adjusted the RH2 in such a way that VCE is equal to 1 volt. Now you can press this button, add to table. Okay, then we have to change the value of RH1 at regular intervals. I have told you in this way. Suppose it was initially, you see, 1 ohm, then we will change it to suppose 5 ohms. Okay, then here if you press add to the table, you will find this collector emitter voltage as 1 volt and the first reading will come. Then we change this RS2 to 10 ohms. Suppose we are varying it in regular interval 10 ohms. Then add to the table. Then 15 ohms, add to the table. Then 20 ohms. Then 25 ohms. Then 30 ohms. In this way, you keep on changing the value to your some other value of RH1 in regular intervals. Okay, so now you have this set of the observations. You can note it down and you can also create a plot if you press this plot button in this way. Okay, now this was your characteristic for common emitter voltage equal to 1 volt. This was the first set of input characteristic. Then you can now clear all the values. You know that we have to take the input characteristics at different values of common emitter voltage. Suppose we have taken the first reading at 1 volt, then we will be just taking the second reading at 2 volt, 3 volt, 4 volt and so on. Similarly, you will obtain a set of curve which is called the input characteristics. So here again, let me adjust the value of RH2 so that the VCE, it is 2 volts. Okay, so here it is 2 volts. Now we will again change the value of RH1 in regular intervals. Suppose now we are taking, you have to take it in the same interval as it was taken earlier. So 5 ohms, then add to the table, 10, add to the table, 15, add to the table, similarly 20, add to the table, 25, then add to the table. In this way you will follow the steps at regular intervals and then you will plot all the values in this way. So here you are getting individual curves for a particular value of collector emitter voltage. Now in the next step you can take this collector emitter voltage to 3 volts and 4 volt respectively. In that way you will again obtain all the observation table and plot the values. So you will obtain 4 curves, and all those 4 curves, they will be representing the set of input characteristics. Okay, so here you are obtaining the curves individually for each value of collector emitter voltage, but in your practical record you will have to plot all these set of curves on a single coordinate, so that you will obtain one set of characteristics. So with this we finish the input characteristics. Then we will come to the output characteristics. Here you can again press this link, the output characteristics, and follow similarly the instructions. You'll find initially both RH1 and RH2 has to be set to 1 ohm here, then RH2 to 1 ohm. Okay. Then similarly you have to set the base current IB to 15 microampere by adjusting the value of RH1. So IB has to be set to 15 microampere. Now it is 10.29. So you have to set RH1 and this has to come 15 microamperes. It has exceeded 15. It should come to 15 something. It's very precise, you see. To get the value of 15, it's not so easy in this. So it's 15.35, let's take. Okay, because I'm facing some difficulty in adjusting the value. So it's IB equals to 15 microamperes. Now what you have to do, vary the collector emitter voltage. This collector emitter voltage VCE is to be varied by adjusting the rheostats RH2 in regular steps. So you can see vary VCE at 5, then add to the table. Similarly 10, 8, 9, 10, then add to the table. Okay, then 15, add to the table. 20, add to the table. 25. So in this way you have to take all these readings, some 10 or 15 readings, and you have to get the plot. Okay, so this is how you obtain the output characteristics. And the output characteristics are between the collector and emitter voltage and the collector current IC. Okay, at a particular value of base current, which is 15.35 microamperes. So in this way you have to perform this experiment and write it on your practical records along with all the necessary things like aim, objective, like your procedure, theory, then experiment, or you can say the observation table, etc. And finally the results and conclusions. Thank you.